In this section, we're going to look at what are called improper integrals. Now, an improper integral is really a redefinition of the integral sign as we know it. Okay? So there are two types that we're going to look at, and then you can extend these, sort of combine them. The first is of the type when we have an integral from a number to infinity, or you might have an integral from negative infinity to a number, but they're basically handled the same way. The second type is when we have an integral from a to b. This is the notation that we'll use, but the limit as x approaches a of our function. We should really have that as x approaches a from the right. As x approaches a of our function, we go to infinity or maybe negative infinity, or perhaps as we approach b from the left, we approach to positive or negative infinity. So for the improper integrals of type 1, we have to redefine what we mean by the integral symbol. So this is a completely new definition. It doesn't the definition we learned when we first learned about definite integrals does not apply anymore. What we're going to do is we're going to look at the integral from a to some number b, and then once we've calculated that integral, we're going to let b go to infinity. For the second type, we're going to do something similar. For the second type, since it's discontinuous at x equals a, we're going to pick a number t that's greater than a and let t approach a from the right, evaluate this integral, which is defined, and then evaluate the limit. When we have improper integrals, it is extraordinarily important to do the limit definition. Alright, so our first example is the integral from 4 to infinity of dx over x minus 2 squared. Okay. Now, when we have an infinite limit of integration, it's obvious that we're going to have to use improper integrals. So the first thing we do is we use the definition and rewrite it like so. So our upper limit we're going to call b, and we'll let b go to infinity. Now, for a while, we completely ignore the limit. We take our integral and evaluate it just as we did before. We have an exponent of negative 2, and so what we'll do is add 1 to the exponent. We have a new exponent of negative 1. We can divide by our new exponent, negative 1, which is the same as multiplying by negative 1. Now we substitute our limits in, b and 4, and subtract. Still, we've done nothing with the limit yet. We have negative 1 over b minus 2 minus the opposite of 1 over 4 minus 2. A little bit of simplification. Now we let b go to infinity. Well, that denominator explodes. Since it explodes, that fraction approaches 0. 1 over 4 minus 2 is still just 1/2. And so we're going to end up with a definite integral, or an improper integral, whose value is 1/2. When we end up with a numerical answer here, we say that the integral converges. Okay. So that's one type of indefinite or improper integral. For the next type, it's a little bit harder to recognize, but what I see here is that if x is equal to 2, 1 over x minus 2 squared is undefined. So that's why it's improper. These are harder to recognize because the limit is not infinity or negative infinity. Okay, but this is going to be improper because that lower limit, the function does not exist there. So what we do is we replace the lower limit. I think here we replace it by a. We're going to let a approach 2 from the right. Okay. We then look at the integral from a to 4. Our integrand is the same that we had before, in fact, x minus 2 to the negative 2. Again, we increase our 1. Our new power is negative 1. Dividing by negative 1 is the same as multiplying by negative 1. We're going to evaluate this from 4 to a, and then let a approach 2 from the right. So we'll have negative 1 over 4 minus 2 minus the opposite of 1 over a minus 2. as a approaches 2 from the right, think about this. We have a number that's very, 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 very close to 2. We subtract 2 from it here. So that denominator that I have there is very, very small. In fact, it's approaching 0. Because it's approaching 0, we have an infinite limit here. Okay? Because a is approaching 2 from the right, the denominator is small and positive. Here we have 2 negatives, which would become positive. This is going to go to positive infinity. So our overall integral, the improper integral, will say diverges, and it diverges to infinity.